Hello everyone, welcome to another IGCSE Maths tutorial. Today we'll be going over these topics: the powers, roots, surds, estimation, and the standard form. First, we have squares, cubes, and their roots. We've already explained this, but we'll go over it again. The square of a number is simply that number multiplied by itself, and it's denoted using x to the power of 2 or x squared. For example, 2 squared would be 2 multiplied by 2, which would give you 4. Similarly, the cube of a number is the number multiplied by itself and then multiplied by itself again, denoted by x cubed. And the cube of 2, for example, would be 8. 2 multiplied by 2 multiplied by 2. The square root of a number x is the number, when multiplied by itself, results in that number x. For example, the square root of 3 is 3. 3 multiplied by 3 would give you 9. The cube root follows the same rule. When multiplied by itself twice would give you that number. The cube root of 27 would be 3. We refer to a number that is being multiplied by itself x amount of times as that number to the power of x. Squares and cubes have special names because they are more important and more frequently used than any other power, specifically in calculating measurements like area and volume in 2D and 3D space. As an IGCSE student, you are expected to know the squares, cubes, and the squares and cubic roots of all numbers from 1 to 15. Powers and indices. Powers, also referred to as indices, singular index, are not restricted to positive whole numbers. They can be negatives, fractions, or even 0. It is very important to know what each of these represents. Fractional indices, for example something raised to the power of 1/2, refers to roots. A square number is expressed as x to the power of 1/2. A cubic root can be expressed as x to the power of 1/3, and so on. Negative indices refer to reciprocals. For example, if the index is -2, the result would be 1 divided by the square of the initial number. So 1 divided by that number, that is the reciprocal, or x minus 1. Then, because there's a 2, you do the x minus 1 and then you square it. Make sure to get plenty of practice with both fractional and negative indices, and even combinations between the two. Sometimes you'll be asked to find the reciprocal of the root, for example. It is also very important to note that raising any number, regardless of the number, to the power of 0 will always result in 1. Now, indices have specific rules when it comes to calculations involving two of the same number with different indices. For example, you're multiplying 2 to the power of -3 by 2 to the power of 5. If you were to multiply them, you get the result by adding the indices up and then calculating the value. For example, if you have x squared plus x to the power of 3 multiplied by x to the power of 3, the answer would be x to the power of 2 plus 3, or x to the power of 5. In this case, we have 2 to the power of -3 multiplied by 2 to the power of 5. 5 plus -3 will give you 2, which results in 2 squared, which is 4. Now, if you were to divide numbers, we would do the opposite, so we'd subtract them. So we have 2 to the power of 5 divided by 2 to the power of 3, which would give you 2 to the power of 5 minus -3, which would give you 2 to the power of 8, or 2 to the power of -8, depending on who came first, if it was 2 to the power of 3 divided by 2 to the power of 5. When dealing with brackets, you simply solve whatever is inside the bracket, and then raise that answer to whatever power was outside the bracket. For example, if you have 2 cubed and the whole bracket is squared, you would get 2 cubed first, which is 8, then you would square that, which results in 64. Surds. Surds refer to the irrational roots of rational numbers. For example, 2 is a rational number. The root of 2 would be the rational root of 2, which is the surd. Same with 5. Some larger surds, for example, the root of 20, can be simplified into smaller surds. You will be asked to do this. You can do this by finding the factors of the numbers under the root. In this case, the factors of 20 are 4 and 5, and you multiply those roots by each other. So in other words, root 4 multiplied by root 5 would give you root 20. And you will notice that the root of 4 can be simplified even further. It can be simplified because 2 squared is 4, so the root of 4 would be 2. And you multiply the 2 by the root of 5 to get 2 root 5. practice doing simplifying surds on their own and in calculations. For example, the root of 200 minus the root of 32. First, you get the root of 200, which is the root of 2 multiplied by the root of 100 to give you 10 root 2, since the root of 100 is just 10. Similarly, the root of 32 is just the root of 2 multiplied by the root of 16. Again, 16 is a square number, it's 4. So you get 4 root 2. And then you go back to the original calculation. 10 root 2 minus 4 root 2 will give you 6 root 2. We will also need to know how to rationalize denominators that include surds. If the denominator is a surd on its own, in this case 10 over root 5, you simply multiply both the numerator and the denominator by the surd, since if it's root 5 over root 5, that's just multiplying by 1. So you would multiply 10 over root 5 by root 5 over root 5 to give you 10 root 5 over 5, since root 5 multiplied by root 5 is just 5. And the answer of that, you'd simplify the 10 over 5 into 2 root 5. Now if the denominator consists of 2 terms, then you multiply both the numerator and the denominator by that, but make sure to change the sign in the middle. So in this example, we have 1 over minus 1 plus root 3. We'd multiply that by minus 1 minus root 3 multiplied by divided by minus 1 minus root 3 instead of plus root 3, sorry. You would get minus 1 minus root 3 over 1 plus root 3 minus root 3 minus 3. Then obviously plus root 3 minus root 3 can cancel out, so you'd get 1 minus 3, which is minus 2. So the answer would be minus 1 minus root 3 over minus 2. Obviously you can multiply this by minus 1 to make it positive. You'd get 1 plus root 3 over 2. Next, we'll be talking about rounding and estimation and the standard form. You likely already know how to round numbers to a specific number of digits, for example the nearest unit, 100, 1000. It is also expected for you to know how to round them to a certain number of significant figures. Significant figures only count starting from the first non-zero digit in a number. For example, the first significant figure in the number 0.0073 would be 7. The leading zeros do not count. And similarly, the first significant figure in the number 5764 would be 5. Zeros in the middle of a number, however, do count. For example, rounding 40,912 to 3 significant figures would give us 40,900. You will also be asked to estimate calculations by first rounding numbers used to a specific degree of accuracy, whether that be digits or significant figures, and then performing the calculation. You will also be asked to find the upper bound and lower bound for values, for example, lengths measured to the nearest meter, or the perimeter of a rectangle when given its dimensions to the nearest centimeter. The lower bound and upper bound represent the minimum and maximum values for a value to be rounded up or down to the resulting value. To do this, simply take the degree of accuracy and half it. Your lower bound will be the value minus half the degree of accuracy, for example half a meter, and the upper bound will be the opposite. These bounds can also be represented in an equality. Lower bound is less than or equal to the value, which is less than the upper bound. In the above example of the perimeter of a rectangle, you find the lower bound by adding up the lower bound of each edge of the rectangle and adding them together. You do each edge separately, you get the lower bound for each one, and then you add them. That is your overall lower bound. And the upper bound can be calculated by doing the opposite. Once again, you take the upper bound for each edge and you add them all together. Finally, we'll talk about the standard form. We can express longer numbers, whether they be large or small, using indices in a specific form, the standard form. By larger numbers, I mean numbers with a lot of digits. You already know that each time you divide a number by 10, you shift the decimal one place to the right, and each time you multiply, you shift it one place to the left. We will simply make use of this to simplify long decimals or big numbers. For example, we can express 47,000 as 4.7 times 10 to the power of 4, and we can express 0.0047 as 4.7 times 10 to the power of negative 3. Practice converting numbers in and out of standard form as well as calculating with them. Thank you for watching. Make sure to subscribe, like, and comment any questions or feedback, and check out our channel for more videos.